So hi everyone, welcome back to this session. So whatever we saw, which was what is return, standard deviation, Sharpe ratio, this all will come very handy in today's session. Okay. So first thing is to get stock data. Okay. First step is always to get stock data, right? So if you look at it, we have in our portfolio, we have three stocks, JP Morgan, Goldman Sachs, and Morgan Stanley. Okay. So let's say in our portfolio, the first thing is we have three stocks. Now, a lot of you might ask, how do we get the stock data? So what I'll do is, okay, so just see, look at what I'll do. I'll write my start date and I'll write my end date. Okay. Then what I'll do is I'll choose my ticker. Okay, I'll choose my ticker. So let's say my ticker is JP Morgan. Okay, so now the next step is I'll write stock history. Okay, I'll basically click on my ticker, which is JP Morgan. I'll choose my start date. I'll choose my end date, and because I need a daily data, I'll write 0. I'll close this bracket and then just click enter. So this gives me what? This gives me the stock price, the closing stock price for JP Morgan. Okay. And if you look at it, the dates have exactly matched January 1st, 21st January 2024, because see, it's a holiday. So that's why we have gotten our data from 2nd January 2024 till the end of the year. Okay. So first tell me, is this step clear? And similarly, what we can do, we can similarly replicate this for Morgan Stanley. So what we need to do, same thing. We'll write stock history. Okay. We need to mention our stock, which is Morgan Stanley, mention the start date, end date, and we'll write 0 because we are looking for daily data and just click enter. So like this, we'll get our stock prices for JP Morgan, Goldman Sachs, and Morgan Stanley. Yes, so stock history is an inbuilt Excel function. Okay, so stock history is an inbuilt Excel function. Okay, so nowadays, what I'm seeing is Yahoo Finance, has created a premium service in which, if we have to download the data, we'll have to pay for it. I believe we need to enter into their subscription plan. So that's why if you are looking for data, you can, get the same data using the stock history method. Okay. All right. So is the first step clear? Please tell me. Downloading the stock data is the first step clear to everyone? How have we downloaded the stock data? So now after we download the stock data, stock price for JP, so as I said, we have three stocks in our portfolio, JP Morgan, Goldman Sachs, and Morgan Stanley, right? So what eventually we'll do is we'll calculate the daily return. So how do we calculate our daily return is if you look at it, today's price divided by yesterday's price minus 1. And this is what we saw in the last session also. To calculate return, what we do is we see today's price, we divide it by yesterday's price minus 1. Similarly, today's price divided by yesterday's price minus 1. Similarly, and we'll use the same formula all across to get our daily returns. Okay. And we'll use the same formula for all our stocks, be it Goldman Sachs or be it Morgan Stanley. So can you tell me, is this step clear? How do we calculate daily return? Please tell me. Is this step clear? How do we calculate daily return? Okay, I'll wait for few of you to tell me if in case you have any doubts in these two steps. For the first step is say downloading the stock data. Okay. The second step is to download to calculate the daily return. Okay. Okay, I'll wait for a minute. I see few clear. Okay, I see few comments on. Okay, so now the next step is once you calculate your daily return, the next step is you need to calculate what is the expected return. Okay, so now we are building this portfolio summary. Okay, so what we'll calculate is what is our expected return for individual stocks, what is the standard deviation for individual stock, what is the variance, and what is the Sharpe ratio. Okay, so basically how will we calculate so expected return is nothing but mean return, right? So expected return is nothing but mean return. So we'll take average of all the daily returns. Okay, We'll take average of all the daily returns to arrive at what? To arrive at the expected return, or you can also say this as mean return. And similarly, we'll take average of daily return for Goldman Sachs and then average of daily return for Morgan Stanley. So this is how you basically calculate the average return. Okay. Or you can say the mean return. The next step is to calculate the standard deviation. How much is your return deviating from the mean return, right? This is what standard deviation tells you, right? How much does your mean return, how much does your daily return deviates from the mean return? So what we'll do is, so in Excel, we have a formula called standard deviation dot sample. Okay. So if you look at this formula, right? So when you write, okay, so when you write standard deviation, it will give you two formula, dot p dot s. Always remember that dot p represents population, dot s remembers sample. If we had taken the data from the start of the, from the start when the company was originated till today, then it makes sense to use standard deviation dot population because we have considered the entire population. But if we are just looking at a sample, if you look at it, we are just looking at a 1 year data, right? So that's why here we'll use standard deviation dot sample. Okay. So if you look at our formulas, what I'm doing is I'm calculating the standard deviation of this daily return for JP Morgan. Similarly, I'll do the similar practice for Goldman Sachs and for Morgan Stanley. Please tell me, is this clear? Please tell me, is this clear? How have we calculated the standard deviation? Now, what does this standard deviation tells me? It tells me how much is my daily return deviating from the mean return. And we have already calculated our mean return, right? We have already calculated our mean return. Now, the next step is to calculate variance. Now, variance is nothing but, if you look at the term variance, it is nothing but the square of standard deviation. Okay? It is nothing but the square of standard deviation. So that's how you calculate variance. Now the next step is Sharpe ratio, which tells you what? It is nothing but the risk adjusted return, right? It is the risk adjusted return. So if we have our return and we have our risk, right? We have our return, we have our risk. So we'll calculate our Sharpe ratio like this. We have our return, we have our risk. Okay. We have our return, we have our risk. So that's how we calculate our Sharpe ratio. Okay, I see one doubt. When we talk about deviation from mean, we are talking about in both direction. Yes, we are talking in both the direction. Okay, Rohit, we are talking about in both the directions. Okay, yeah. So now, because see, eventually, if you look at here, see, if you look here, 388 to 381, we see a negative, negative. It goes, the stock is swinging in negative direction. But if we look at 3 from 381 to 382, it is swinging in a positive direction, right? That's why here you see, if you look at here, we have negative return. Why? Because the stock price actually it fell down, but here we see a positive value because the stock actually grew, right? So when we talk about deviation, it is in both the direction. Okay. So what it will look at is, okay, this is the mean. This is the mean. How much is individual returns deviating from the mean? And this is why we saw this example in the previous session, right? How can we calculate standard deviation? So now, as I said, so this is how we calculate our risk summary. Is it clear? So first step is, download our daily stock price, then calculate the returns. Okay, simple returns. Then for simple returns, as I told you, we divide today's value by yesterday's value. Okay, and subtract one format to get return. Okay. So similarly, we'll follow the same steps for all the days. Okay, for all the days. Okay, to get daily returns for daily returns for the whole year. Okay. So for expected return or mean return is the same thing. Okay, I can write, instead of expected return, I can write mean return, or it's fine, expected return or mean return is the same thing. Okay, just take the average of individual returns to arrive at standard deviation. They take standard deviation dot sample and just take this whole array. Okay, take this whole array. Okay. So this is how you get standard deviation. This is variance. Just take the square of this, the standard deviation, you get variance. And Sharpe ratio is nothing but you divide the return by the risk. That's it. Is this clear? Please tell me. Is this clear up till now? How have we calculated the portfolio risk summary? Okay. Now we'll look at how do we calculate the covariance matrix. Do you all remember what is covariance matrix? It tells you how stocks are moving together, how one stock is moving with the other stock, right? How one stock is moving with the other stock. Okay, so I see one question. Variance value should be greater than standard deviation. Uh, Okay, so you are right, Mahesh. The variance should be greater than standard deviation only if in case where when the value is greater than 1, right? See, if you look at this 1.48%, 1.48%, this is nothing but 0.0148, right? If the value is less than 1 and if you take square of this, it will be lesser than the standard deviation value, okay? What you are saying is right, but it's something like this, okay? Let's say we have two values, 0.5 and 2. Let's take let me take number. Okay, so let's say we have two values. We have 0.5 and 2. Okay, now if I take square of these two terms, if I take square of these two terms and if I check if this term is greater than the other term. Okay, so what it is giving is false and it is giving true. Here it is giving false. Why? Because this if the standard deviation is less than 1, if it's between 0 to 1, the square of it will always be lesser. But if it's greater than 1, the square of this will always be, higher. I hope this clears the doubt. Okay. So now, how do we calculate the covariance matrix? As I said, covariance tells you what, how two variables or how two stocks are moving together. This just tells you how, if we have a positive covariance value, it means it is moving in a similar direction. If we have a negative covariance value, it means it is moving in a negative, both the stocks are moving in opposite direction. So to basically calculate the covariance matrix, we'll go into data, okay? And then, okay, okay, my bad. We'll go into data and we'll look at, okay, just give me 1 second. Home, data. Yeah, we have data analysis. And here what we'll do, we'll we'll look for covariance, okay, and we'll select okay. And then eventually it will ask me for input range. So what will I do? I will give this whole input range, okay? And then I will say what? Let the output range be here. Let's say let the output range be here, okay? And I'll click okay. So eventually, if you look at it, it has given me what? It has given me my covariance matrix. Okay, it has given me what? My covariance matrix. So what I have to do, I need to go on to data, okay, and then I need to click on data analysis. That's it. I need to go on data. I need to yeah, data analysis, and this will give me what? This will give me what? The covariance matrix. Similarly, similarly, to look out for correlation matrix, what I'll do is data analysis, and here I'll write correlation. Okay, please repeat. Okay. So basically, the way to calculate covariance matrix is nothing but I'll go on data, I'll go on data analysis, and then I'll go click on covariance. Okay, I'll click on covariance, I'll click on OK, and then it will ask me what for input fields. Okay, it will ask me for input range. So what range I'll give you? I'll give the daily return. Please do not make this mistake of giving the stock prices. Okay, what we need to give is the daily return, and once we have given a daily return, I'm saying that the output should be here. Output should be here and just click OK. And this gives me what? This gives me my covariance matrix. Similarly, see, Similarly, if I want to calculate my correlation matrix, how will I do? How will I do? I'll click on data. I'll click on data. I'll click on data analysis. I'll click on correlation. Okay, I'll click on OK. And similarly, input ranges, again, the same thing. We'll give our daily returns for all the three stocks. The output range, let's say, is here. I want my output to be here and just click OK. Okay. And this will give me what? This gives me what? This gives me my correlation matrix. So what I'll do, let's do this in percentage term. And as I know, JP Morgan, Goldman Sachs, Morgan Stanley is here. So that this will also come here. And similarly, this will also come here. Okay. So I'll just take transpose. So so now, because now if you look at it, if you look, okay, so I'm not, okay. So Ragnish, I saw your question. Basically, I'm not using any feature. If you go on data and if you go on data analysis and then you click on correlation or covariance, you will automatically get it. Okay. If you click on data, see correlation and covariance metrics are there. So it's an inbuilt, I would say it's the inbuilt function that Excel has. Now you will see we do not have certain values, but can we fill these certain values? The answer is yes. So this is nothing but the correlation between Goldman Sachs and JP Morgan. Okay, this is nothing but the correlation between Goldman Sachs and JP Morgan, and this is exactly this value, right? The correlation between Goldman Sachs and JP Morgan. So what I'll do is I'll just write this here. Okay. Similarly, what is this? The correlation between Morgan Stanley and JP Morgan, which if you see the correlation between JP Morgan and Morgan Stanley is this. So I'll just fill this value here. Okay. And similarly, what is left is the correlation between Morgan Stanley and Goldman Sachs. Okay. So the correlation between Goldman Sachs and Morgan Stanley is this. So I'll just fill this value here. Okay. Is this clear? How have we, so this is nothing but this value, this thing. Okay. Is this clear? Please tell me, is this clear? Okay. Now we have all seen, okay, now we have all seen the portfolio risk summary. Now we need to optimize our portfolio. We need to optimize our portfolio. So let's assume, okay, let's assume that we are investing equally. We are investing equally in each stock, 33%, 33%, 33%. Okay. So eventually, if you look at it, this gives me what? 100%, right? So what I'm saying is I'm investing equally in all the stocks. Okay. I'm investing equally in all the stocks. Is this the best way to, is this the best strategy? Please say yes or no. To invest equally in all the stock, is it the best strategy? Yes or no? No, right? So this is where the concept of mean variance optimization will come in. But before that, let's say if we have this stock, let's say we have this equal weightage of stocks. Can you tell me what will be my expected return? So this is nothing but W1 times mu1 plus W2 times mu2 plus W3 times mu3, right? Do you all agree or not? So what I'm saying is, okay, let's say what I'm saying is here I have my individual return. So to arrive at this, to arrive at expected return for the portfolio, what I'm doing is I'm multiplying W1 with R1 plus W2 with R2 plus W3 with R3. This will give me what? My mean return of the portfolio. But then this return is for daily return, right? This is daily return of my portfolio. To arrive at yearly return, to arrive at yearly return, what I'll do is just multiply the daily return with 252, right? Because why 252? Because we have 252 trading days in a year. If you remove all the Saturdays, Sundays, and the national holiday, right? If you remove the weekends, which is Saturday, Sundays, and the national holiday, the number of days that will be left is almost 251, 252. Okay. So that's why this is our daily return, daily expected return, and to arrive at the yearly return it is 37 percentage. Okay. Similarly, okay, now to arrive at the portfolio standard deviation, To arrive at the portfolio standard deviation, what I will do is, this is the formula that I'll use. I'll multiply the weight with the covariance matrix, and then I'll multiply that again with weights. Okay, this is a very standard practice of calculating the standard deviation of the portfolio. So what I'll do is, I'll multiply the weights. So to arrive at the, if you look at it, what I've done is, first is I've taken the square root. Okay, first I've taken the square root, then this m mult is nothing but matrix multiplication of, if you look at these are nothing my weights. Okay, I'm multiplying the weights with my covariance matrix. Okay, I'm multiplying the weights with my covariance matrix, and again multiplying it again. If you look at it, so first I'm doing this. Okay, first what I'm doing this thing, which is multiplying my covariance matrix with transpose of my weights. Okay, this will give me these two value, and then again multiply with weights. So that's why after we get this, we again multiply with weights, and then take square root of it to to arrive at the standard deviation of the portfolio. Please tell me, is this clear? Please tell me, is this clear? So eventually what we are, just to summarize it, what we are doing is, see, we are utilizing this formula, which is take the square root of weight transpose times the variance, the covariance matrix times the weights. Okay, so this is a very standard formula for calculating, the standard deviation of a portfolio. Okay, if you have, let's say, multiple stocks, right? So what eventually I'm doing is, if you look at here, so first thing that I'm doing is I'm calculating. Okay, okay, so someone says zoom please. Okay, I hope this is clear. Okay, so what I'm doing, if you look at it, what I'm doing is, first I'm doing the matrix multiplication. And matrix multiplication is a concept of linear algebra. And this is why linear algebra is important, okay? So matrix multiplication of my covariance matrix with the transpose of weights. Okay, with the transpose of this Q7 to S7 is what? This is nothing but my weights, right? This is nothing but my weights. So I'm multiplying this matrix with the transpose of this matrix. Okay, so this will give me this value. Now after this, I'll again do a matrix multiplication of weights with this whole amount. Okay, and then I'll just take the square root to arrive at the standard deviation of the portfolio. And once I have the standard deviation, this is my daily standard deviation. To arrive at the yearly standard deviation, I'll multiply this value with the square root of 252. So one thing to remember is, when you are calculating the daily, when you are calculating the yearly return from the daily return, you multiply with 252. But when it comes to standard deviation, you multiply the daily standard deviation with the square root of 252. Okay, this is a general standard practice which we follow in the industry. Okay, and then the last step is, all of us know, which is to calculate Sharpe ratio. Okay, this is Sharpe, Sharpe. Yeah. So to arrive at the Sharpe ratio, it's nothing but return divided by the risk. Okay, so did you all understand this part? Please tell me. This is more like how we calculate. So this was, if you look at it, this was individual risk summary. Okay, this was individual stock risk summary. Okay, but here what we have calculated is portfolio risk summary. This is more for a portfolio level. Okay, now the concept of mean variance optimization. Now the concept of mean variance optimization will come very handy. How to use mean variance optimization? Tell me one thing, what will we optimize? Will we optimize weights? Is that will be optimized? Please tell me. Yes or no? Yes or no? So let's say we have something okay, so let's say what I'll do is, let's say I have 33 percentage. Okay, let's say I've invested 33%. Okay, let me do this. All right. So, okay, so let's look at how can we perform, how can we optimize our weights? How can we optimize our weights based on the standard deviation? Okay, this what we are doing minimum, this what we say as minimum variance portfolio. Minimum variance means we are reducing the variance. Okay, we are reducing the standard deviation basically. Okay, so what I'll do is I'll run a solver. So what I'll say is data. Okay, I'll do solver here. Then in the solver, what I'm saying is, in the solver, what I'm saying is, okay, so let's say what is my objective function here? Objective is this thing. I need to make my standard deviation minimum. Okay, need to make my standard deviation minimum by changing what? By changing these cells. Okay, by changing what? By changing these cells. Okay, and what are the conditions? That first condition is the weights should be greater than 0. Okay, the weights should be greater than 0. Do you all agree? Do you all agree or not? And the total amount of weight should be equal to 100. So this basically, if you look at, okay, let me delete this. So I want to add one more condition, which is this should be equal to 1, which is 100%. Okay, this should be equal to 1. So essentially what I'm trying to do is I'm trying to minimize this value. Okay, q17 is this value, right? I'm trying to minimize my standard deviation by changing the weights. And what are the constraints? First constraint is, of course, the weight should be greater than 0, because we are not assuming any short selling. We are only assuming that we are going long in the portfolio, which is we are only buying stocks, we are not selling stocks. That's why we have put the weights greater than 0. And the second thing is we need to assure that the sum of the portfolio, sum of the weights should be equal to 1. Okay. All right. So let's solve this. Let's solve this and let's keep the solver solution. So if you look at it, what it is saying, if you look at it, what it is saying, if I want to minimize my return, oh sorry, if I want to minimize my standard deviation, I have to invest everything into JP Morgan. I have to invest everything into JP Morgan. And let's confirm it. Let's confirm this. If you look at this individual summary, can you tell me which one had the lowest returns? Sorry, which one had the lowest standard deviation? It is out of all the three, JP Morgan had the lowest standard deviation. So if we want to build a portfolio with the lowest risk possible, we'll invest all our money into JP Morgan. Please tell me, is this clear or not? Please tell me, is this clear or not? How did we arrive at the minimum variance portfolio? Is this clear or not? Please tell me, is this clear or not? How did we arrive at the minimum variance? Now, what we'll look at is how can we maximize our return? Okay, please tell me, is this clear? Okay. Now let's look at how can we maximize our return. Okay. So in this case, we were reducing our risk. In this case, we'll try to maximize the return of the portfolio. So what we'll do is, again, the same thing, we'll go at data. Okay. And then what we'll do, sorry. Okay, okay, so now let me go on data. Okay, for some reason. Okay. And I need to go on data analysis. Okay. Okay, data analysis. Now, sorry, I need to go on solver, my bad. So I'll go on solver. Now what will I do? Can you all tell me? Here what should I maximize? Set objective is, okay, I want to maximize the expected, sorry, I need to optimize my return, right? I want to maximize my return by changing what? By changing my weights. By changing my weights. Okay. And these two condition will remain as it is, right? These two condition will remain as it is, that the first condition is what? Okay, so what I'll do is, okay, let me delete all of this. delete. Let me also tell you how to add constraints. So I'll tell add, okay, and I'll do what? I'll basically say all this should be greater than equal to 0, okay, and I'll add one more constraint that this value, the sum of all the three weights, should be equal to 1. So I've added the constraints. Now what will I do? I will put solve, okay, and if you look at it, it has solved, okay. Eventually, okay, what I should have done is I should have changed the portfolio to show you how it has solved. So let's say this is okay, so let's say this is my portfolio. Let's say this is my portfolio. So let me run the solver again. I'll write data and I'll click on solver and then I'll run. So if you look at it, we if you look at it, it is trying to maximize this value by changing the weights here, by changing these weights, and then these are the two conditions, right? So let's click on solve. So once we click on solve, okay, and if you look at it, what it is saying is, okay, if you invest all your money into Goldman Sachs, this will give you your highest return. This will give you your highest return. If you just look at from individual returns, can you tell me in which case was the return the highest? In which stock? If you look at it, Goldman Sachs had the highest returns, right? Goldman Sachs had the highest returns, right? That's why it is saying that just invest all your money into Goldman Sachs and this will give you the highest return. But from a diversification, from a risk from a risk let's say let's think from a risk side of things. Do you think it's a good practice to invest all the money into one stock? What will happen if you invest all the money in one stock? See, definitely your returns have gone very high, 42% for the whole year. This is really high returns. But if you look at the risk has also significantly improved, right? If you look at risk here, it was the lowest risk was 1.37, but in this case, what is the risk? The highest risk is 1.62. So basically, the movement of the stock is almost 26%, right? So portfolio is really volatile in this case. And the last step is, so we have achieved what? Minimum variance, maximum return, right? The last step is maximum Sharpe ratio. So can you tell me how will we use the solver for maximum Sharpe ratio? Can you all tell me? Can you all tell me like how can we use the solver? So I'll go on data, I'll go on solver, right? And then eventually what I'll do, I need to so so this is my objective function. I need to maximize my Sharpe ratio by changing what? By changing my weights, okay? By changing my weights, and the condition is first is these weights should be greater than equal to 0. All the weights should be either greater than or equal to 0, and one more condition is this value should be equal to 1, okay? The weights should be equal to 1. All right, so let's solve for this. So once we have solved, this is what we'll get. Okay, once we have solved, this is what we'll get. See, eventually I did not change if you just, okay, if you want, I can just do it in front of you again. Let's change the, weights. So again, solver and just solve. If you look at what I have gotten, same thing, right? So eventually, if you look at the Sharpe ratio, it has increased. If we compare these Sharpe ratios, we had 0.10, but here what we have gotten 0.11. So we have definitely increased the Sharpe ratio. Okay. So is the mean variance optimization model clear to everyone? Please tell me. Please tell me, is this clear to everyone? So just to summarize, what we have done in the mean variance optimization is first we have downloaded the stocks. We have basically calculated the daily returns. Then here what we are looking at is basically we were just calculating the individual stock. We'll calculating the summary for individual stocks, right? So we looked at what is the mean return, standard deviation, variance, Sharpe ratio, right? For the all the stocks. But when we look at portfolio, things becomes very different, right? Because expected return is W1 R1 plus W2 R2 plus W3 R3, where W1 W2 W3 are the weights, R1 R2 R3 are the mean returns, right? Similarly, the standard deviation formula becomes this for the portfolio, and then the Sharpe ratio is just the same return divided by risk, and then we achieve the what we say as minimum variance, wherein we saw that the standard deviation was the lowest. Then we achieved the maximum return, where we saw the expected return was the highest, and then we achieved the maximum Sharpe ratio. All right, is this clear? Please tell me, is this clear? Okay, so let me stop this recording. Are there any doubts on this? Please tell me. Are there any doubts on this? Okay. If there are no more doubts, let me stop the recording.